play.
Oh, wait. I actually cleaned out that restaurant for them. It's for the three sisters. There's a guy who owns it.
That's Rodney Coughlin. Talking about Rodney Coughlin.
No.
Let's do it. So on your test, there was a problem, or either it was homework, I can't remember, but you had something like, actually, let me make this, let's put a 3 in there. Something along those lines. And you said, why can't I pull the exponent around, multiply in the front, and then just subtract 1 from the exponent? Somebody was asking about that. Do y'all remember that? It might have been you, Robert. You or Matt. It worked for that one, and I said, well, it works this time, but it won't always work because...
It was because the reason it doesn't work is
what's inside the parentheses. So here's what happens. Can we all see that this is a composite function? It's like a function within a function. Remember how we did f of g of x? So if I said that this was like f of g of x, do you see that this is really like x squared? And into x squared, I have plugged in 3x plus 2. Does that make sense to you? Okay, so when I have a composite function like that, if I have something like f of g of x, what I have to do is I have to peel this back like an onion, okay? I have to do the derivative of the outside first. Now, I could FOIL this out, right? But everything doesn't lend itself to do that. So I would do the derivative of the outside, leaving that inside alone, and then I'm going to multiply by the derivative of the inside. That's why I was doing blow pops today. Candy outside to get to the bubble gum inside. I'll try to remember to bring them tomorrow, yes. Please do, remind me. Maybe at like 7 o'clock so I can stop by Food Line on the way, because I doubt I'll remember on the way home.
Oh.
Send me a text at 3:30 and then send me a text at 7 in the morning. I'll put a reminder on my phone in just a second.
what are you reminding?
I was supposed to bring y'all blow pops today.
Oh, what's that?
Yeah, so that you could remember the layers, because it's the different layers. I'll buy a couple bags. All right, so if I'm looking at something like this one, the derivative here, so the outside first, which is that x squared part, right? So 2, and I leave the inside alone, but I'm still subtracting 1 from the exponent. Now I have to chain it, so I have to multiply by what's on the inside, which is 3. So Robert, the one you were asking about just had like x inside, x plus something, and it worked because the derivative of x is 1, right? So this will be 6 times 3x plus 2, which would be 18x. Say again? So you always work from the outside in, right? So I took the derivative here of this whole outside first, and I brought that around, and then I did the derivative of the inside. Think about like an onion, you got to get, or like the blow pop, you got to eat the candy before you can get to the bubble gum, right? Right. The derivative of 3x plus 2. Now, if you FOIL this out just to prove a point, 3x plus 2 times 3x plus 2 would give you 9x squared plus 6 plus 6 would be 12x plus 4. And what's the derivative here? 18x plus 12. It's kind of cool, right? So you don't have to FOIL everything out. All right, let's practice. Then we'll actually do some. It does make things easier. It makes things a lot easier. Is it what? Is that it? Is it new? Yeah. It's hiding here.
Yeah, I don't hear it.
This is really, we'll do a lot with trig functions here too. You get a good one. Before I do a trig function. Find the derivative of f. You think that's hard?
So what are we doing? Find the derivative.
I would do it as 1 over square. I would, if I was doing this one, I would change this negative a half. X squared plus 3 to the negative 1/2 is what I would do there. I would. If there were no radical, I'd have it as a -1 if it was just in the bottom still. If there was something in the top and the bottom, I'd probably do quotient. Not here. She in your group? Are you in their group too? You're always multiplying by the chain. What would be 1? Yep. Outside in. Always outside in. Yep, I would. I would leave it just like that. I mean, if you wanted to rewrite it, you could write it as x over the square root of x squared plus 3 cubed. But, I mean, either way is fine. There was that negative out front. What's the derivative of 1? Minus 1. -1/2 minus. Remember, multiply in the front. So negative, negative a half, and then subtract 1.
Yeah, that's what
What's the derivative of 1? I'm taking the derivative of each piece, right? Because that one's added or subtracted.
But because it's still the negative side.
Y'all good? Yeah, but we're going to do most of it with trig functions. Contain yourself, Mac. I know you're super excited to do this, but great day. What happened? Oh, yep. Either one of those is fine. You don't understand this? Do we need to do another one like this? Well, you took, oh yeah, this was 2x. Negative a half minus 1. Let's do another one. This is number 20. find dy dx. And see you thinking from here. Before you start manipulating and simplifying, make sure you got the process right here. You only had to change this in one place. It was when you got to the second part of the numerator there, right? I did the derivative of the top times the bottom. Or you could have put these together and done product rule. Is that what y'all did? Yes, and then did product rule. So you made this x times 1 plus x squared to the negative 1/2. I'll show you both ways. You can do it either way. You'll come back to the same thing at the end. If I'm here, did anybody do quotient on this one? Nobody? Really? All right, derivative of the first times the second plus the first times, and now I got to do derivative of the second. Negative 1/2, 1 plus x squared. I guess I'll just come over here and do it because that's what y'all do. And then I have to chain it.
I thought we did the other. I thought we did the.
So you could go through either one. This is quotient first and then the product on the right. But both of them require chain. There wasn't a variable in front. Yeah. Right? There was no variable there in front. Where? After I took the derivative, but prior to. So now if I clean this up a bit, I get 1 over the square root of 1 plus x squared plus, actually that's going to be a minus, because I got this negative right here. 1/2 times 2 is 1. And then I got 2 x's there. So I got x squared times 1 plus x squared to the negative 3 over 2. They do. They're both the same. And I use chain on both of them. Here, see, I chained the inside because I took the derivative of that x squared here. Same thing here. This was just product versus quotient was all this was. You can do it either way. If you see a function within a function. Let's do another one. Chain's where you'll mess up because you'll forget them. Everybody always does until you start really getting them. I need to Good. Ooh, we do implicit differentiation here. Let's do. Find the derivative. Okay, so chain rule is completely separate from product and quotient. Okay, you're always going to use product or quotient if you have two things multiplied together, product, two things divided, quotient. The chain only comes in whenever you look at what's inside of what you've done and you can take a derivative again. In other words, as I look here, right, if I take the derivative of the top, there's no other function in there. And if I take the derivative of the bottom, there's no other function in there. But up top here, right, I've got that radical. So here, I'd have to do the 1/2 and subtract 1, but then inside, what's left over is still a differentiable function. It's still something I can take the derivative of. So if inside you can still take the derivative, you still have to take the derivative. If you can ever write it as a composite function within a function, this is square root of x and x cubed plus 1. F of x would be square root of x, g of x would be x cubed plus 1. So what I really have is f of g of x. Plug g into f. Do you see the difference? You see how it's a function within a function? Because this just tells me that I'm going to have to chain. That's all it does. Okay. All right, derivative here, let's do the first one first. Derivative of the top is 1 times the bottom minus the top times derivative of the bottom. Why don't I need to chain here? Right. Do y'all see that? There's not a function within a function. This is just a function in and of itself. And technically, if you said x was the function, what's the derivative of x? Is 1. Okay, let me finish writing this. All right, so what would the function within the function be here? This is what I wrote in green over here. The top is the square root of x, right? I mean, the top is, one of the functions is the square root of x, one of them is x cubed plus 3. So I could really write it as f of g of x, which tells me I would need to chain. So here, first thing I'm going to do is outside. Always work from the outside in. So the exponents first, yes, because this is like to the 1/2. So I got derivative of the top, because I'm still in quotient rule, right? Because that's a quotient. So derivative of the top would be 1/2 x cubed plus 1 to the negative 1/2. But I'm not done with that derivative because I have to do what? Take the 3x squared. Right. Because that's the derivative of the inside. I'm working from the outside in. You think so? Derivative of the top times the bottom Right. You know how before you would have to like put them together and then you could take the derivative? Here you don't have to. You can just take the derivative. That's what the chain says. The chain says take the derivative of the outside and then multiply it by the derivative of the inside. Minus, yep, the top times the derivative of the bottom. All over bottom. Oh, I did. I forgot it. Sorry. Yeah. Thank you. I'm not going to worry about cleaning this up just yet because right now I want you to see the concept. I don't want you to get lost in that. Yeah. So this is derivative of the top times the bottom minus top times derivative of the bottom. So really the only new thing here is taking the derivative of this.
Why did you take the 5? So that first part, why did you take 5?
This is the bottom. This is the derivative of the top.
So
That's the derivative of the top. Right. That's the new times the bottom. Again, I'm not focusing on cleaning this up. We'll get there whenever we get this chain rule down. For right now. Now, you will have to. Just right this second. Hold on. What's the derivative? Look at y'all. You said you wouldn't remember. I told you you'd remember some of them. For right now. We're going to come. I don't want you bogged down in the algebra right now because right now I want you to worry about chain rule. I just want you to see the difference in how the chain rule is operating as opposed to what we were doing before. And when to recognize, when to use it. That was why I had 2 there. So you know, I didn't use it on the first fraction, but the second fraction I did need it. What if I changed this and said, well, what if f of x was the sine of 2x? What's the difference? I know. Well, they work out more. They will be closer. All right, tell me again, what's the difference?
well, now it's
Now it's times 2, which means I have what? Right? A function within a function, right? I've got a composite function. So if I operate on that chain rule concept, right? What derivative am I taking first? Of the sine, which is what? Cosine. Leave that inside alone, yes? But don't forget to chain here. So here, f of x is sine x. G of x would be 2x. So I've got f of g of x, right? And so to take the derivative, it's outside times derivative inside. Which you actually did here, but what's the derivative of x? Now I'm fixing to crank it up. Ah, you really don't. It's just 2 cosine 2x. I think the trig functions are easier than the big rational functions myself. All right, let's see what you got. Yes. Should we do a double chain? Let's do a regular chain first, then we'll do a double chain. Oh, me. This, by the way, is number 4 on your homework. I know, I've been waiting to get up to chain rule for so long. I can hardly stand it. You hate this? Chain rule is your friend. Find dy dx. Mark that guy. Well, think about it. I want you to think. Just think about it. It's Stella's favorite song. You're the only person in the world that likes that song. You what? There's really not much else you can do with it. These don't have a whole lot of manipulation. Ryan!
No, no. It was a quote. I think you got it. She told that. Oh, she told me that. No, she told me.
What's your outside function? What'd you do first? Secant squared, right? Did you remember that or did you look it up? Did anybody remember it? But listen, sine, cosine, and tangent, you'll remember it, no problem for sure. Am I done? No, because I got that bubble gum in the middle, right? The bubble gum. I really need those blow pops. So multiply by what? Be very careful here. It's not multiplying to this. That's all part of the secant function, right? It's multiplying. So move it to the front so you don't get confused. Because you don't want to start trying to FOIL that out because that would be wrong. So 2 minus 3x squared, and make sure that's in parentheses, secant squared 2x minus x cubed. Okay. Hold up. Y'all are doing good with this so far, though. I like that better than yeah. Limits? You liked limits? Y'all are the first class I've ever had that liked limits. Maybe I moved slower through that because in anticipation of y'all not. Now, volumes of revolution, those are going to be a little tricky. That's the very last thing we do, though. Yeah, it revolves around the axis and makes a three-dimensional shape and find its volume. I didn't want it to get confused to multiply with this because that's part of the secant function itself, right? And so I just wanted to keep it separate. You can leave it that way. I'm about to give you a good one. I'll start getting to where I make you do a little more with that. Just not yet. You can do this. You can do this one. It's not as bad as you think it is. Yep. Remember, when you see a function in a function, chain it. I don't know, is it? That's what I'm asking you. Maybe it's... That's right, lady. I want you to find the derivative. How you get 0? But that's multiplying. That's whenever you're multiplying. You're thinking this is not 4 plus the square root, da, 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 da. So you don't take the derivative of this. And the, for this, it's just what happens whenever you have a coefficient out front and you're taking the derivative. Just throw it in the front. Just throw it in the front. Derivative of x is 1. What's the derivative of a constant? Yeah. Remember how we talked about those derivatives? Y'all are getting caught up in the easy stuff. What's the derivative of this? Right? Or what's the derivative of this? Right, so I could really take that 5 out and just do the derivative of this, which is just 2x, which gives me 10x. You don't have to do product here. You could, but you don't have to. What do you mean? So f of x, I would say, is 4 square root of x, and I would say g of x is secant x plus tangent x. No, what's wrong, Robert?
I don't know.
Do the same way you've done before. Let's look at what we got and let's work outside in. What do you mean? 4 times 1/2 x to the negative 1/2.
That's not.
Yes. Well, now, right, and you never do because you pull that. Remember, if you've got a coefficient, you pull it out front of the derivative. Anytime you have a coefficient in front, I can bring that in front before I even take the derivative. Right? So if I do the derivative of this, so I'm going to ignore that 4 right now. And I'm going to make this 1/2. So now I have 1/2 times what? But now I have to chain it. Oh, sorry. Yep. There you go, Stacy. Get together. You don't understand this? You did this much.
No. I didn't.
Okay. Yes. What? That's what you're supposed to do to clean it up. So you got a 2 there. Yeah, absolutely. That's how I do it because that's how I see it also. As I see it, I'm just going to go ahead and multiply it. But everybody's getting caught up on the 4. So either way, it's one of those things you can do either way. Yes, you can just do 2. Yeah. That's yeah. That's what you can do. Yeah. Y'all were getting caught up in that 4, and I was telling you at the end of the day, it's just like whenever you do this. We always just know it to be 2 times 5 is 10, but really what's happening is I'm ignoring that coefficient in the front, and I'm taking the derivative of x squared. No, I didn't. I did say that? No, okay. Thank you, Avery.
I thought the whole point of it was not.
Not to do what? I haven't even chained yet. I'm halfway done with the problem. Okay, let's derive the inside, right? I haven't made it to the bubblegum yet. Here I am. What's the derivative of all of this? So I've got to take each piece, yes? What's the derivative of secant x? Secant x tan x plus, what's the derivative of tan x? Pull out your little hot pink sheet. Secant squared x. Yes. And I am multiplying all of this. Okay, this is kind of an easy one to clean up. This looks worse than what it is. Wait. This is 2. Look, all of this is in the top. Secant x tan x plus secant squared x. All of this is in the bottom because it's got a negative exponent. I could even do this if I wanted to. Whoa, why did I do that?
Well, that makes it not right.
Calculus has different rules. You can leave radicals in the bottom.
That's because it was under
What?
a radical.
Yeah. You're talking about where did this come from? Where do you see a second? Right here? Oh, yeah, that was, I was erasing to make room. Sorry. I didn't see it either. So this would have a positive 1 exponent, right? So it stays in the top. I went ahead and multiplied these two together to get the 2. And then this just moved down to the bottom since it had a negative exponent. No. Do you see the outside end? Do you see that? Do you see the function on the outside working your way to the end? Yes. Well, it's 4 times a half, and all of this is not a square root, but it's a square root in the bottom because it's a negative exponent. Y'all need a breather for a second? What does this look like when I start that? Ah! That never, every single thing we do from now on. S of t is my bug moving along the x-axis. Find the velocity at any given time. You can do this. There you go, there you go, she's right. The derivative is, yes, because it's constant. Pi over 2 is still just constant.
Oh, dude, that's
Did y'all remember to chain it? That's what I have. I know, I don't know what y'all are talking about. What's wrong, Joyce? 0. What'd I do?
but why did you not do that?
When my bug takes off, what's his initial velocity?
Why did you not take the derivative?
Absolutely right. All right, so I said what when my bug takes off to start with, right? What's his initial velocity? Because he's shot out of something apparently. So I'm plugging in 0 for what? For time in my velocity equation, yes? So my initial velocity when I change it. Whenever I said, hey, what's the derivative of this? Well, the derivative of that is -3. But everything, whenever I start doing that chain rule, everything inside has to stay the same. I do the derivative of the outside, that inside stays exactly the same, and then I do the derivative of that inside. You don't know what? Here's that unit circle again. What's the sine of pi over 2? I'm right up top. 1, right? So I got 3 times 1. So initial velocity is yes or no, Robert? No, Joyce.
But I feel like
Well, tell me where I lost you on that one.
I just don't really understand the idea. Yeah, I get what you're doing, but I don't understand my color.
Today, yeah. Let me do this one, and then I'll do one that's got a chain within the chain here so you can see what's going on. How about this one? How about the derivative here? And remember, this is exactly the same thing as this, if that helps you. Okay. Derivative. Remember, chain says outside in. What does it look like? Several of y'all aren't seeing, but I can already see. You're not seeing the composite. 2x. 2 sine x. 9 times 1. Why? Look at you. All right. All right, so you take the derivative of the outside first, leaving the inside alone, and then you take the derivative of the inside. So that's why I wrote it like this. I thought it'd be easier to see. Really here,
Yeah, it was. No, you are, I don't think you are. It was last year. And there's somebody looking at her. So what's you guys' favorite F-word? Because we're doing like
I remember. I will never forget
I
that.
was like, that is not my favorite F-word.
To be honest, I'm gonna be honest. Like when that happened, I just meant that I did it like factoring, but then I thought about it and then.
Y'all were very supportive that day. I appreciate
It
that.
out, and I just meant that I did it like factoring.
Okay, Avery, what's your question? Okay, so the first thing I did was I did this power rule, right? 2 times, how else could you do it? Okay. You'd still have to do power first. The only thing that you could do is you could write this as sine x times sine x, and you could do the product rule, right? Which is the way you'd have had to do it before we talked about chain rules. So I'd have to do derivative of the first times the second plus the first times derivative of the second, which would be 2 cosine x sine x. And if I keep working over here, I get the same thing. Yeah.
All right, so how is this one
Chain. If f of x is x squared, g of x is sine x. Yes. The exponent there. Yes. Okay. Wait. I thought Joy said wait. Oh, she said wait, and I said wait. Okay. Find the derivative. I will give you a hint. You're going to have to chain this one twice. Okay, let's do. Okay. I will. I'll go back to that one. Let me give you one that doesn't have a double chain. I know. Which number did I say that was? 22. Let me give you this the way that it's written in your some of your homework problems so you'll know what to do. Cross out what? Oh, yes, I will. So this one says, find the derivative at a specific point. I just wanted you to see, I know. Okay, so listen, this says, the directions say find the value of f of g of x, the derivative. This is g of x. It's very wordy in your book, but I just wanted you to know they're good problems. I just wish they weren't set up this way. I wanted to show you how to set them up. So if I go in here, what they really want you to do is f of x is pi x plus 1 over cosine squared. Dang it, this is another double chain. Okay, and so what they want you to do is they want you to find the derivative at 1/4. In other words, find the derivative and then plug in 1/4 to evaluate. Okay, let's do that. Well, the first one's easy, right? It's just pi. 0.
So we're plugging in 0 now? Or 1?
No, we're just taking the derivative. I feel like I have failed y'all in this lesson so terribly.
Every time, every question is something different.
Y'all think these are different? What's different about it?
Why are we not
Oh,
plugging in?
I think I'm.
Are we waiting? How many times?
We'll do that last. We'll plug in 1/4 last. I wouldn't do quotient here. I would change this to that.
Okay, that's what I'm saying.
Well, because it's 2 in the bottom right now. This I could write as cosine -2x. Okay? So outside in. So the first thing I'm going to do is the outside. So I'm going to handle the, right? We got to subtract 1 from the exponent, okay? Now, inside, negative sign, but I leave all of that gobbledygook alone. Mm-hmm. Because the inside of this had a derivative also. It is like from the outside in, 1 step at a time. Derivative, leave everything inside alone. Peel that layer, go to the next one. Derivative, leave all this inside alone. Peel that layer, inside. We need an onion is what we need. An onion.
No, you need one of those like a big old thing.
You know what we need? One of those Russian dolls that the inside and the inside. You know what I'm talking about? Yeah.
Oh, yeah.
And inside's a smaller one, and inside's a smaller one, and inside's a smaller one. The inside doesn't change until you touch the outside and fix
So you
it.
just keep finding it.
That's exactly right. I did it myself. I bought a kit off of Amazon. I know, they did too. I'll get better. That's the first time I've ever done it. I went outside. Well, but this is the dip, so it doesn't come off. Yeah, I bought a dip. I tried to get her to let me. She's like, I'm good. She said she didn't want me to mess them up for homecoming and then have to take them off and redo them. Okay. No, you're not gonna pay me. Let's do. Oh, we haven't finished because it said evaluate at pi at 1/4. We're definitely gonna spend tomorrow on this as well. All I'm doing is, this looks worse than it is at this point. I'm just plugging in that x value. Here's the nice thing though. Each of these insides are going to become pi over 4. And pi over 4 is a super easy value for you to remember because it's the only one that has the same one, and I'm in quadrant 1. The same coordinates. Square root of 2 over 2. That's exactly right. Both of them are going to be positive. So here I'm going to have pi minus 2. Well, the cosine of pi over 4 is root 2 over 2 times negative root 2 over 2 times pi. Yeah, I'll stop here. I won't give you anything quite that hard. Which one's negative 2? Yeah. Where do you see negative 2? Negative 2, root 2 over 2? That was my original derivative. Oh, because it had a negative 2 and I multiplied it. All right, let me give you